Page 2 of the Unit 3 test. Page 2. All right. Now, with an equation like this, we're going to need to factor. But before we factor, there's a few things we can always figure out. For instance, let's look at the degrees. Degree 3, degree 3. Since they're equal degrees, the horizontal or oblique asymptote, it must be a horizontal one. It must be y equals 3 over 1 or 3. And if it was, if you might have to do long division, or you might have and be 0, you're just looking at the degrees. And the y-intercept is easiest right here. 0, 0, 0, putting zeros in for the x's, minus 54 over, and if I put zeros in here, I get minus 8. And so my y-intercept, if I put in 0 for the x's, I get minus 54 divided by minus 8, which is 27 over 4, I think. Divide both by 2. Yeah. 27 fourths. That happens to be 6.75. And I might as well put some of this stuff on the graph while I'm getting it. So there's a horizontal asymptote at 3, y equal 3, and a hole at 0, intercept, y-intercept at 0, 6 3/4. So it crosses there. Okay, now let's go to factoring this. And so I turn my calculator on, and you can see, and I've bumped stuff here. This looks like 3x squared plus 12x squared minus 9x plus minus 54. I have it over 1, but which doesn't do anything. So that's the numerator. So I'm going to graph that. I'm going to turn this other equation off. And I'm going to go zoom 6. And this is the numerator. Looks like it bounced at minus 3. So that means x plus 3 must be squared. And it wants straight through at 2, which means x minus 2 must be a factor. And I see a 3 in front of this, and if I multiply this out, I'm going to have x times x times x. I'd have 1x squared, and it's supposed to be 3x squared, or x cubed, instead of 1x cubed. So I have to have a 3 in front of that. And that's one thing that many people miss on this test. You got to get that in there. Now let's look at the denominator, which happens to be what I typed in here, I believe. X to the third plus 2x squared minus 4x minus 8. Always good to check what you typed in, because you may messed up, whether you're doing the calculator or Desmos. So now I'm going to graph this one, and since it bounced at negative 2, that means x plus 2 must be a factor, and since it went through plus 2, that means x minus 2 is a factor, and this one has a leading coefficient of 1, and x times x times x is 1, so that is correctly factored. And so now I can look at this and say, okay, if there's a hole, there's a factor in the numerator that cancels the one in the denominator, like that. So that's telling me that 2, because 2 minus 2 is 0, at 2 there's a hole. And to figure out the y value of that hole, I put 2 into the rest of this equation. So 2 plus 3 is 5, squared is 25, times 3 is 75. And then 2 plus 2 is 4, squared is 16, and that's where the hole is going to be. Well, 16 times, let's see, 16 times 5 is 80, so this is 5 less than 5, 4 and 11/16. Or you can change it to a decimal value. Okay, I'm going to put that on the graph. At 2, 4 and a little over half, it's 0.6 something. There's a hole there. Okay, let's do the vertical asymptotes. Well, now that we've got a factor, we see there's one at -2. And since it's squared, the behavior is they're going to go either in the same direction. So I'm going to write same. Nope. Yeah, same. I thought I wrote it in the wrong place. So at -2, a vertical asymptote, and they go in the same direction on either side of that. Well, now we've got a pretty good idea that this is going up like this. It hits the hole here. And then this is the horizontal asymptote, which approaches as it gets very far out there. So it must go like this and up, snuggling up, getting asymptotically closer to the vertical asymptote there. And let's see, we got it coming, so went the same direction, so it's got to be coming down. Now let's see where it goes. X-intercepts. Well, back here we have an x-intercept at -3. Now, intercepts are points, so I got to say at -3 we get a 0. And what's its behavior? Well, since it's squared, it's going to bounce there. So it's bounce or straight through or something like that for x-intercepts on the numerator. And for vertical asymptotes, it's either same or opposite, depending on the degree of the factor. And on the oblique asymptotes, what happens when x gets very large? It approaches, x gets large, the curve approaches y = 3. So that's what the whole point of the horizontal or oblique asymptote. It approaches that. So we got to get a bounce at -3. Well, if it's coming from up here, it's got to be coming down and bouncing there. And it has to go up here because it went in the same direction at this vertical asymptote. It bounces, and then there's no other x-intercept, so it can't go down. And then the end behavior is it's got to approach y = 3. So this has got to come up and approach y = 3. Getting closer, not curving down or up. So, local maximum. Is there a high hump someplace in this? Not here. This keeps going up. This goes up to infinity, goes up to infinity. This comes down, so there is no hump, so there's no maximum. And is there a minimum? Yes, it comes down to there, gets to 0 as the minimum height there. It happens at -3, but I don't have to write it. This keeps coming down and down and down, so there's no minimum there. There's no low spot. So there's the local minimum. Sketch the graph. We've done that. Got all the important things: vertical, horizontal, hole, y-intercept, x-intercepts, all the important stuff shown on my graph. Now I just have to decide for what x's is the y height less than or equal to 0. Well, this whole graph is greater than 0 except for right there. There's the only place where it's equal to or less than 0. And that's at -3 to -3. it's equal to 0, and that's the only answer to that one. And that's page 2.